Calculating pH. Strong bases. Sodium hydroxide, potassium hydroxide, and barium hydroxide are all considered to be strong bases. They break down and release hydroxide ions, and this is what turns them into a base. And the reason they're strong is because they fully dissociate. So for example, let's say we had 1.2 molar sodium hydroxide. Now remember, molar is just another way of saying moles per decimeter cubed. That means we're going to get 1.2 mole per dm cubed hydroxide ions, and also the same amount of sodium ions. Let's say we had 0.008 molar potassium hydroxide. Again, we're going to get the same amount of potassium ions and hydroxide ions. How about if you have 0.1 molar barium hydroxide? This time, we're going to get 0.1 molar barium ions. However, we're going to get 0.2 molar hydroxide ions, because notice that one molecule of barium hydroxide will release 2 hydroxide ions. All 3 of these are strong bases, and they all fully dissociate. Let's try a question. Let's say we have 100 centimeters cubed of 0.5 molar sodium hydroxide, and we want to calculate the pH. Remember that pH is minus log of the concentration of hydrogen ions. However, the products here are not hydrogen. Instead, we have hydroxide. So if we're going to have to work out pH, we're going to have to convert this hydroxide into hydrogen using something called Kw, the ionic product of water. Now Kw can be expressed as the following: the concentration of hydroxide ions multiplied by the concentration of hydrogen ions. We're going to do a separate video on the basis and the principles of Kw, but for now, just make sure you understand this expression. Okay, so you can see here that we have an equation which has hydroxide ions, hydrogen ions, and Kw. To work out hydrogen ions, all we're going to do is rearrange it like so. Now all we have to do is work out the value for Kw and hydroxide, and there we go, we have hydrogen ion concentration. Since the solution had a 0.5 molar sodium hydroxide, that means the concentration of hydroxide ions will be 0.5 molar. Perfect. Now as for Kw, the value is always going to be 1 times 10 to the minus 14 at 25 degrees Celsius. So make sure you remember that Kw will change with temperature. And if the question is not at room temperature, in other words 25 degrees Celsius, for example it might be at 30 degrees, they will give you the temperature and the value for Kw. If they don't, you can just assume it's 1 times 10 to the minus 14. So we can write here 10 to the minus 14. So that means the concentration of hydrogen ions will be 2 times 10 to the minus 14. Okay, now that we know the concentration of hydrogen ions, all we have to do now is minus log it. And that gives us a pH of 13.69. And that makes sense. Considering it's sodium hydroxide, it should have a pH that's close to 14. And that's how you calculate the pH of strong bases.